says
really mean
coconut.
thing. It makes really mean.
They're drugs and they're drunk.
Alrighty, so.
And
What? She did.
wait, you gotta wait until it's live.
And we're live! Alright, so let's get the review packet done. We got a mega quiz tomorrow. We got a lot to do. What?
Still leaving me out. I still need one.
You need one? What?
Yeah, I need one too.
What the hell?
Schlaffer! Why'd you do such a bad job at
What'd
this?
you put in the water?
Wait, oh god, I'm supposed to pass these back.
No, you're not. No, you're not. I swear.
I have mine.
Every day. We do not pass it back.
What
No.
the hell is all this then?
Wait,
It's the entire packet. It's thick. She's thick with receipts.
Oh shit, my bad.
Turn everyone off.
Bobby!
You thicker than Kathy with the K.
I can talk shit about my mom. We're
Kathy,
I don't
you-
talk shit about Maggie.
Divide
I
tray.
don't talk shit about Maggie. Do it. It's good. No, out of respect, I'm not going to talk shit about her. Just
Everybody sit down. This is geometry class.
Can we stop?
This ain't shit talk class
Sit down,
101.
Kayla's mad at somebody.
Oh my god, I was.
Autumn took Ian to, I want to say Pound Town, but that's.
Schlaffer, shut up. Schlaffer. I'm not joking around. Shut up. Okay? We attempt to not be stupid in here, everybody. Thank you. Alright. Let me read some more copies and we'll get this going. Sorry I didn't have enough. Numbers are hard. How many more do we need? Who needs one? One.
Who needs to have
Oh, yeah, hey.
Two.
Sorry.
That's better.
God bless America.
And we're live.
Okay, cool.
And
So,
wait,
go for the real quick. James,
here we go.
This water is a
you were in charge.
That is sad.
You put JD in charge.
That's kind of scary.
That is the dumbest decision
Alright,
I made ever made in his
I
life.
did not mean that in a sexual term.
Oh, no, I know.
I don't know
Sit in
what
the camera.
He's a
Sit in the
surgeon.
camera.
Jacob.
What is going on?
No,
Do it.
He was being
you hesitate too long. Like, that's
Yeah, that's not. Yeah.
Just kidding.
He's back.
I guess I didn't hit print. I don't know why that's the case, but I didn't hit print.
Now it's accurate. I wasn't doing it no matter
Try this
what.
again.
Shit ass.
Right, you did a good job, but not great. You're in charge.
What? Damn, that's tough. I get it. I just put my head in this going. Damn.
Because that's where I'm at.
Okay, Haley, you're in charge, so let's declare a boxing match.
walking. They make me
Fight for the throne.
That's dark.
Why did you just kiss me on the forehead?
What justice?
That's dark.
Illegal.
What's my dating Jacob? Is dating Jacob. What? That's why I was like, yes.
Your mom.
You tried to kill yourself?
No.
Hang on, transfer the arm.
No.
So angle your arm like that.
Hair back like
I got
She doesn't have her mom.
You are just the
There we go.
best goofball I've ever met.
I was trying to be cool.
Yeah.
You tried too much.
All right. So
You're a bot.
first things first. Write the given down for both of these. What did they give you in this diagram that we need to write down?
Numbers.
I'm going to get it in a second. It's printing, okay? They gave us that we have two sets of parallel lines. What are the two sets? PQ and MN. So write that. Given that P and Q are parallel, right? And that M and N are parallel. So that's the first bit we got to write down. Okay? Ladies, I'll get you your stuff. It's just got to print, okay?
She doesn't want it.
P parallel to Q and M parallel to N, okay? We need this for both of these. If you forget it tomorrow, you will lose points because I want to give you points for something that's easy. Inevitably, you are going to screw it up, right? So let me go grab the stuff.
Do you have to put that like?
I cannot see. I want to be the Ferrari.
seriously, what?
That's nice.
It just sounds so bad.
Oh my god, that thing is very
Please come and see.
All right, here we go.
So who threw that one?
Not really.
Mac, who threw the paper airplane and the pencil sharpener?
Oh my god, they're warm.
It's not a coincidence. It's happening purposely.
Here you go.
Oh, they're warm.
All right. For real now, we gotta go. What?
Who did that one?
I don't know. I think it was somebody in the hallway. All right, so given P is parallel to Q and M is parallel to N, we can now go about proving that 3 and 15 are congruent. So here's 3. Here's 15. Guys, we got to go fast, so make sure you're paying attention, all right? So 3 and 15 are going to be congruent. How do we get there? We can't just do it in one fell swoop. We got to take some steps. How would you do it? So 3 and 11 are congruent. We know that because if you look, we've got two parallel lines cut by a transversal M, which means corresponding angles will be congruent by CAP, right? Cap. So we know 3 and 11 are congruent, so let's write that down. 3 is congruent to 11 by cap. Now we're here. Will 11 be congruent to 15?
Yeah.
Yes, it will, because we have two parallel lines cut by a transversal, which means 11 and 15 are congruent, and we know that by what? CAP again. And then the magic happens, right? We're going to do some substitution here. We know that 11 is the same thing as 15, so we can switch them out. Again, you don't need to write the purple stuff. I just did that for you. That means 3 is congruent to 15 by substitution, right? SUBS, not SUBT or SUB because that's subtraction property, right? So they're congruent by substitution, and that's what we wanted, so swag box, we're done. There are more ways to do it than just that, but that's probably the most efficient way. Well done. Are you smelling what I'm stepping in?
Yes.
Okay, the writing is a lot, but if you see the logic, you're going to be good. All right, number 2. I know, you guys are actually good at proofs because I'm proud of you guys, okay? I don't have time to gush over it, but seriously, I am. All right, angle 10 and angle 7, we're proved that they're supplementary. Okay, so here's angle 10. Let's do that in pink. Angle 7 is blue because we know it's going to be corresponding with 3, right? So 10 and 7, they're not going to be congruent necessarily, right? But they are going to be supplementary. How do we prove they're supplementary? How would you go about it? Yeah.
Can you go, angle 10 and angle 8 are congruent due to alternate exterior?
Can't do that. They're too far apart.
Okay.
Couldn't you do the vertical angles? Vertical.
We could do vertical to get 12. That's true, but that's not really going to get us anywhere. What do you see?
It's corresponding to 2 and it's alternate, not alternate exterior, is it alternate? Same side.
Okay, don't worry about same side, alternate exterior, any of that stuff. Just worry about vertical angles, corresponding angles, and linear pair. Okay? I think you guys are trying to use that to cut corners, and it's screwing you up. Okay? So let's go back to basics. Let's prove something supplementary right off the bat. No, you weren't wrong. I mean, you were in the second part, but like, I think if you think more simply, we'll be okay. So 10 and what are supplementary?
9.
10 and 9 are supplementary. That's true. We can do that. Okay? How do we know 10 and 9 are supplementary? How do we know they are? LPT, linear pair theorem. So we know angle 10 and angle 9 are supplementary. And we know that by LPT, linear pair theorem, right? They're a linear pair. They're on line M. Now that we know that we have 9 and 10, how are we going to get to 7 and 10? Can't do it yet. It's going to take a couple moves.
10 is 15. No, 10 is 14. No, yes. 10 is congruent. 10 and 6. 14 scissor 16. 16 is the same as 7 CAP.
I'm just going to walk you through this one, okay? Because there's a lot of different ways to do it, and you guys are doing a really inefficient method, but that's fine. We're going to stick with it. So if we're going to say 9 and 10 are supplementary, I would then say, look, 9 and 1 are the same. How do I know that?
CAP.
By CAP. So let's write that down. Angle 9 is congruent to angle 1 by cap. You guys are definitely my most creative class. I'll give you that.
For reasons.
Okay? So 9 and 1 are congruent. Now that I've shown that 9 and 1 are the same, 1 and 5 are the same by cap. You dig?
Yes.
Let's write that down. Angle 1 is congruent to angle 5 by cap. There's a more efficient way of doing this, so if you're overwhelmed by the number of steps, I know why. I'll show you how I would do it, okay? And now that we know 5, how do we get 5 to 7? Vertical. So scissor theorem. Angle 5 is congruent to angle 7 by that. Now check it out. We're going to use the transitive property for the first time officially in here. Normally we just do substitution, but there's a lot of substitution to be made here, right? We know 5 is the same as 5. We know 1 is the same as 1. We know 9 is the same as 9. So there's going to be a lot of substitutions in order to get 7 all the way up here, right?
Yeah.
So instead of writing that all out, what I'm going to do is by the transitive property, because 7 is touching 5, 5 is touching 1, 1 is touching 9, 9 is touching 10, therefore 7 is touching 10, right? That's transitive property. So I'm going to write angle 10 and angle 7. They're not congruent, remember. They are what? Very good. So I'm cutting out all those middlemen. And that's by the transitive property. Transitive. Okay?
That wasn't that confusing to me.
That's okay. I'm going to show you how I would do it, which I think is a little bit more efficient. Less steps, okay? It doesn't require vertical angle theorem. So I'm going to show you how I would do it. Any is valid as long as it makes sense. Okay? So this is valid. I'm going to show you in the diagram without writing it down. So I would say 10 and 11 are supplementary by linear pair theorem. 11 is 15 by cap. 15 is 7 by cap. Transitive property, 10 and 7 are supplementary.
Yeah, that makes sense.
You dig? Less steps.
Mint.
Okay.
It doesn't matter which one we do it, though.
No, as long as your logic is valid, you're good. Okay. Oh, and by popular request, right? All right.
Swag is the back.
Ready? Page 2.
Ew.
They tell you that angle 7 is 85 degrees. So here's angle 7. That's 85 degrees, which is, you know, a little warm, but not too bad. Angle 10 is 115. They give us that. They want us to find the measure of all the other angles, and we want to state how we know that. Vertical angles, linear pair, corresponding angles, postulate. Those are our things. So in order to save time, because we have a lot to get through, I'm just going to label the diagram, and I'm going to say out loud how I got it, okay? So check it out. I know, if I look at 10, are 10 and 14 going to be congruent?
No.
No.
Why not?
They're not parallel.
They're not parallel. P and Q are not. Common mistake. They're not. So cover up what you're not looking at and ask yourself, do I have two parallels cut by a transversal? No! So 10 and 14 aren't the same. Are 10 and 2 the same? Sound like Bartos, right? 10 and 2. They will be the same because we got two parallels cut by a transversal. The transversal is P, right? So those are both 115. And then by vertical, I get these as well, right?
Yes.
Cool. So I use cap to get those. I use vertical to get those. Same dumb crap for angle 1 and angle 9. And then 9, 11, too soon, are going to be vertical angles, right?
Yes.
Ha ha.
All right, question. Are 1 and 5 going to be congruent?
No.
They don't look like it, but looks can be deceiving, and I'll show that to you in a second, right? These two angles are not going to be the same because P and Q are not labeled as parallel.
Yeah.
So we don't have two parallels cut by a transversal. Whole different world down there. So, crap, I used red.
Excuse me?
Let's change this to black.
Okay.
Sorry, I used red twice, and those angles are not congruent. Okay? We know 5 and 7 are the same by vertical.
Yeah.
I know 5 and 13 are the same by cap, because if you look, we have two parallels, V and W. They're labeled as parallel, cut by a transversal. Vertical angles for there. So those are all 85. I also know that 14 and 6 are cap, right? And 16 and 8 by vertical. How do I figure out what the red angle measures are?
180 minus.
Exactly, 180 minus 115, because these are supplementary by linear pair theorem. You dig? So if I do 180 minus 115 in our heads, let's do that. What's 180 minus 100?
120.
80.
No.
80. Subtract 10. 70. Subtract 5. 65. So that's going to be 65. All the red angles will be. If I know the black angles are 85, I know the green. The pink angles are going to be whatever's left over from 180 because they're supplementary, right? So what's 180 minus 80? Hundo. Subtract 5. 95 degrees.
That is boiling hot.
I did that by LPT. We good?
Yep. Oh, my fight.
That's not as much information to process as I thought it would be.
Turn the page. 11. Find the measure of each angle. Check it out. We have two sets of parallel lines. So if I cover this up, I'm just going to mark angles that are congruent before I even get going on this, right? I know 1 is going to be the same thing as 3 by vertical, right? Are 1 and 5 going to be congruent by cap?
Yes.
Yes, because we have two parallels, M and N, cut by a transversal P, right? So those are congruent as well. Same thing for 2 and 4, 6 and 8. Look at another two intersections. I'll take the top two. Are 1 and 9 going to be congruent? Yes, they will, because we have
sir.
two parallels and one transversal. So check it out. All of these are going to be congruent, and all of these are going to be congruent. Yay for double parallel lines. Now, what does that tell us about the expression 3y plus 10 and 8y minus 50? They're equal. Now, a lot of you guys will say that, but then be like, what do I do now? Well, you write that, right? Write what you know. 3y plus 10 equals, they don't add together to 180. We know that they equal each other. Now, this is a true statement. Will it be helpful?
Yeah.
It will. We have one variable, one equation, right? The variable is y. I'm going to subtract 3y and move over the 50 at the same time. So I get 60 over here, and I get 5y over there. When I divide y by 5, I get y is 12. The problem's goal is to find the measure of each angle. So we're not done, right? We need to go back and find the measure. So we're going to plug that in. Now, I know 8y minus 50 and 3y plus 10 are the same dumb crap. I'm going to plug it into this one because that's easier to do in my head. What's 3 times 12?
36.
Add 10.
46.
So all the red angles are 46 degrees. You do not need to explain why. Okay? Now, the blue angle right here is going to be supplementary with the red, right? So what's 180 minus 40? Now subtract 6 more. 134. Again, looks can be deceiving. 134 is a very obtuse angle. Look at angle 2. Does that look obtuse? No. Looks can be deceiving. It happens. Get over it, okay? Just because they look like they're congruent doesn't mean they are. Just because they look like they're obtuse doesn't mean they are. It's not drawn to scale, okay? So again, that's it, as long as they're labeled accordingly and I know they're all congruent. I would encourage colors always. If not, you could do something like this, right? If it was in black and white, and you could have all these guys be with two.
That's exactly what I did.
You see what I'm saying?
Wow.
Like you could do that,
Yeah, that's a good idea.
right?
That's exactly what I did, Chief.
Wow.
12. Solve for each variable. So we'll be done when we have an answer for x and an answer for y. Before I start, I've got two parallel lines cut by a transversal. So let's mark angles that are congruent. This angle right here corresponds with this angle right here. And they will be congruent because we have two parallels cut by a transversal. Cool. So that tells us that these are congruent by vertical. So what do I know about 9x plus 12 and 4y minus 10? They equal each other. Now, true statement, but will it be useful?
No.
No, because we have two variables for one equation. What we really need to find out is what's the relationship between 9x plus 12 and 3x. 3x is different, but notice those are corresponding. So they're going to be supplementary, right? Do you see it now after I write it there? Okay, they're the same, so we can call it the same thing. So we know that 3x plus 9x plus 12 is going to be 180. They're supplementary again. Get my x's together. Terrible idea in real life. Great idea in math. We have 12x plus 12 equals 180. If I subtract 12 from both sides, I get 12x equals subtract 10, I get 170. Subtract 2, I get 168. And then I divide by 12, and you're going to get 14. Trust me on that one. The way I did that in my head is I know 12 times 12 is 144.
I think you got Dennis beat for human
Okay?
calculator.
And then two more groups of 12 gets me to 168 from 144. Trust me on that, okay? But you could figure it out. 12 times 10 is 120, right? We got to go 48 more. 48 times 4, or 12 times 4 is 48, so there you are. X is 14. Now, we need to go get y. Doesn't say we have to plug it back in, but we're going to do that because it's going to help us out. If I know x is 14, I know 3x is what?
Oh.
Let's do it in our head. What's 3 times 10?
30.
What's 3 times 4?
12.
Add them together.
42.
42, the life, universe, and everything. Douglas Adams. Any Douglas Adams fans in here? Hitchhiker's Guide to the Galaxy.
It's also a very good movie.
3x
It is,
equals
yeah.
42.
Zoe Deschanel. What?
3x equals 42?
Yep, because x is 14, and 3 times 14 is 42. Now, we know the blue and red angles are going to be what? Supplementary, so that means we know that 4y minus 10 plus 42, right? That's what we said earlier, but now we have 42 instead of 3x, is going to equal 180. Now, that is a helpful statement, right? Negative 10 and 42 makes positive 32 when I subtract 32 from 180. Let's do that in our heads. 180 minus 30 is 150. Subtract 2 more. 148. So we have 4y equals 148. Let's divide 148 by 4 in our heads. What's 8 divided by 4?
2.
2. What's 40 divided by 4? 10. So we're up to 12. What's 100 divided by 4? 25. What's 25 and 12?
37.
Yeah, add 10, then add 2, right? 37. So y equals 37. I'm proud of all of you. Well done.
So on a test, do we have to label the rest of the angles?
Nope, it just says solve for the variables. Ready? Turn the page.
Where are your gods now?
Trapezoid.
Yep, it is a trapezoid, but what we're interested in is finding the transversals and the angles, right? So forget that it's that. Let's extend it. So what I'm going to do is I'm going to grab my protractor, right? And I'm going to draw the parallels. I'm going to extend those out.
I don't know.
Pick one up at the Farm and Fleet, right? I'm going to draw this line right here and extend it out because it's going to help me see that we have a transversal here. Red is the transversal, 2 parallel lines. That tells us that this angle right here and this angle right here are vertical. So they're the same. Also, if you look, isn't this angle here and this angle here corresponding?
Yes.
Again, ignore that line. Corresponding angles are congruent. That means 3x is the same as that because of vertical. So what does that tell us about 3x and 5x minus 20?
Same.
They're the same. Will that be a helpful statement? Yes. One variable, one equation, so we're good. They are equal to each other. Now I'm going to subtract 3x from this side, add 20 to the other. I get 20 equals 2x. Divide by 2 to everything. We get 10 equals x. Okay? We're solving for each variable, so box that. That's our first variable. Now that we know that x is 10, I can start filling in these angles. That's going to be 30. That means this is 30 as well because they're congruent. Also, you could do the math. 5 times 10 is 50 minus 20 is indeed 30. What do you notice? What is this?
Triangle.
It's a triangle.
180.
Triangles are called triangles because?
They have 3 angles.
3 angles, very good. And the 3 angles always sum to?
180.
180, which means 2y plus 4y plus 5x minus 20 is 180. Now, that wouldn't be a helpful statement. It'd be true, but it wouldn't be helpful. But we know that this is 30, so we get rid of the x, right? So we know that 2y plus 4y plus the 30 we just acquired should give us 180 in total. Interior angles of a triangle. We subtract 30 from both sides and combine our y's. I'll do it all in one fell swoop. We get 6y equals 150. Now, fun way to think about this, right? Instead of dividing by 6, couldn't I divide by 3 and then divide by 2? Isn't that the same thing as dividing by 6?
Yeah.
What's 150 divided by 3?
I think we should divide by 2.
50. What's 50 divided by 2?
25.
25. The only thing funnier than 24, right? I might not know 150 divided by 6 in my head, right? But I do know 150 divided by 3 and then divided by 2. You could also divide by 2 first, right? Get 75, and then 75 divided by 3 is 25. It's up to you.
Might say that a little louder, but
Like in 14.
How you like them apples?
they're sour and disgusting.
Yep. Okay.
I like
Fuji. All right.
Oh, God.
Damn.
All right, this is the one where we have to draw the auxiliary line, right? So we're going to draw it right here and split x into 2 different parts. And then we're going to solve for those parts separately and then add them together, and that's going to be the whole of x. So there's part of x is the red angle. The other part of x is the blue angle. They're not halves, okay? That's assuming they're just 2 different parts, okay? So let's go get the red part first. If we cover this up, I think you can see we have 2 parallel lines, because I drew this in and called it parallel, right? 2 parallel lines cut by a transversal, which means the corresponding angles will be congruent, which means these 2 angles will be the same. What is the measure of the red angle?
62.
62 by vertical, right? So that means this part of x is 62 degrees. Smell what I'm stepping in?
Damn.
All right,
Damn.
down here. It might help if I extend this out a little bit, so I'll do it. Here it is, okay? These are corresponding, so that's 144. That means this is 36. What does that make the blue angle? 36. You smell what I'm stepping in?
Oh, yeah.
This angle here, 144, corresponds with the angle up top. If I extend that out, right? I extended the transversal. Here's the 2 parallels. That means supplementary, this is 36.
Oh, that's
So that's 36.
Yeah, that's awesome.
Right? So this is 62. That's 36. That's going to be x combined, right? 60 and 30 makes 90. 2 and 8 makes 8. So we're talking 98 degrees, which is a boy band from the 90s. They sing the song at the end of Mulan, True to Your Heart. They still exist to this day. I looked them up. That's sad.
How old am I?
Like old. Like 40s.
That's old.
Yeah.
40.
For a boy band? Yeah.
Imagine,
They still like make music.
imagine a bunch of 40-year-olds
I thought you
on
meant like
stage.
I know.
alive or dead.
What about Leonard Skinner?
No, people still listen to their music.
How do you feel about that?
Okay.
Deece, not as bad as you thought, right?
It's a half.
This stuff I'm alright with. The other stuff
15. What is slope?
Rise over run.
Rise over the run. So M is slope because parlez-vous français, and it is the rise over the run. Good. Now, what does it mean to rise? What are we talking about here?
Go up wide.
Go up. We're changing vertically, right? Y is the vertical variable, so we have vertical change, horizontal change, right?
Can we just write up or across?
No. That's kind of what we did here, right?
I guess.
Okay. So, what does it mean to change? Well, change is distance in another way, right? How much we've changed between 2 points. So, when we talk distance, we're talking subtraction, and when we're talking vertical change, we're talking about the difference in the y's, right? So, y2 minus y1. Again, if you know what it means, it all flows from there. Don't memorize this crap. Know what it means.
Little triangles.
Triangle means change. That's delta, the Greek letter delta. You'll see that in calculus and other stuff, right?
Oh my god.
Yep, it just means the change. It just means change.
I didn't know what that meant.
It's not a variable, it just means change. Okay? And change is going to be subtraction. Same thing with distance.
Miss Grimm has taught us all year. Thank you.
We speak no evil.
That wasn't evil. I'm just being honest. Just like do this thing.
Nope, stop dogging. We speak no evil. All right. What does this represent? That's the explanation part. Y2 minus y1 is what kind of distance? Ver-
Are you kidding?
what kind of distance? Vertical distance. Thank you. And the bottom part is representing what kind of distance?
Horizontal.
That's right.
Is that an actual question? Oh, that's crazy.
Yeah, it's an actual question. I gave you the whole page to do it. Ready to turn the page?
Oh, you're just trying to fool us.
I'm just
now,
trying to intimidate you, yes.
Nobody stepping in.
So you have to
Okay,
get
man, tell me the quiz is shorter than this.
Is the quiz ever the same length as the review guide?
No.
Why do I make the review guides really
By a
big?
lot.
5 to 6 questions.
2 reasons. 1, everybody loves samples, right? So I give you lots of samples to practice, because in theory you could study. 2, if I take off questions, I spot you those points, right? I don't need 20 of these.
Unless you fail.
I can put 2, right? Unless you get
Yeah,
below
I'm welcome
65,
right
which
now.
means you didn't deserve them anyway. Right? Let's be honest. Because the only reason I'm spotting the points is because it was saving you time. But if you don't know the crap, I don't need to save you time because you could just turn it in and get it right. Okay, cool, awesome, and then I wouldn't have to grade as much. Anyway, we're gonna find out whether these 2 lines represented by these 2 points, there's 2 points there that make a line, there's 2 points there that make a line, if they are parallel, perpendicular, or askew. Askew meaning that they're neither, right? They just hit at some random angle. If they're parallel, it means they never intersect, which means they're at the same angle, which means they have the same slope. If they're perpendicular, what's the relationship between the slopes? Flip and negate, right? Flippy, flippy. Change the sign, right? Askew is just neither, right? If it's neither of those 2, then it's going to be askew. Again, think about it. If they're not parallel, then they have to intersect. And if they're not perpendicular, then they're not going to hit at 90 degrees. They're going to hit at some other angle, right?
So it's askew.
Askew, right? I ask you. So, how do we do slope? Well, we did it on the last page. Slope is the change in the vertical direction over the change in the horizontal direction. So instead of plugging it into the formula, which is going to cause it to have double negatives occasionally, you guys are going to screw that up, let's do it in our heads. We know what slope is. It's the change vertically. So we look at the vertical values, the y values, and we ask ourselves, if I go from -2 to -1, how did I change? I added by 1, right? So that's our vertical change, otherwise known as our rise. If I start at 0 and I go to -2, how did I change going to -2? -2. So there's a couple ways to represent that. You could have also done the negative up top. Again, it depends on what direction you're going, whether you thought of subtraction or change or how you thought of it. Another way to write it is just the negative on the outside. That's the slope of this line. Now we're going to compare that slope to the other slope. And if they're the same, they're parallel. If they're opposite reciprocals, then they are perpendicular. And if it's just some other random number, it's askew. So, -3 going to -4, how did I change? I subtracted 1. We want 1 down, right? And if I go from -1 to -3, how did I change? -2. So I have 2 negatives. 2 negatives when you divide make a positive, so it's a half. So the slope for equation 2, line number 2, is a half. These are similar, but they're not the same, are they? So they are not parallel. Are they perpendicular? No, because while they are opposite sign, are they flip of each other? No.
Neither.
So it's neither. They are askew.
Will you take points off for saying either?
No, I won't, because I know the directions from the homework, which you did. God bless you. Said neither. Okay.
yeah.
Totally.
About that.
Right. So, do you feel like you can do these?
No.
Yes.
David,
Honestly, yes.
Uno mas, please.
Uno mas?
I probably won't fit.
Schlaffer. I'm on 7 and I'm going to 9. How did I change?
2.
I went up 2. Schlaffer, don't write anything down. I'm on 6 and I'm going to 6. How did I change? 0. Ooh, undefined. So we have a vertical line there. This guy's slope. We're going from 1 to 10. How did I change?
9.
Up 9. I'm going from -1 to 5. How did I change? I added 6. Think about it. I'm at -1. I go to 0. That's 1. Up to 5. That's 5 more. 6 total. Are the slopes the same? No. Are they opposite reciprocals?
Neither.
Neither. Askew.
But, like, 9 to 6 is not the same slope as 3 over 2.
It's not.
If they're the same.
Those two are not the same.
Oh, you're comparing both
Yep.
of
Bam.
them.
Got it.
Alright.
Problem this small, but he just didn't see it.
Okay.
That's what it's all about. Thank you for asking questions.
Nice.
I would hate for that to be the thing that screws you up. Like, you're good at everything, you just didn't see that. Yeah. Turn the page. Write the slope-intercept form. Okay, first of all, what is slope-intercept form?
M equals y.
M equals the slope formula, right? M equals. It's the formula for slope. What is slope-intercept form?
Damn.
Oh.
That's
Why?
that. Yeah.
Sorry.
M equals is slope formula because it gives you
Y
slope.
equals M. I was trying to be-
We call this slope-intercept form because this is the one with the slope
And intercept.
and the intercept. Which intercept does it give us? The x or the y?
I was gonna say
Why?
The y-intercept, right? They call it B because the A is for x-intercept because x comes first in the alphabet.
Of course.
Of course, right? So we needed to write an equation like this. The equation they give us, they want it to be parallel to.
Jeez.
Is this equation in slope-intercept form?
No.
Yeah.
Yes, it is, which means we get the slope for free. What's the slope of this equation?
3, 4.
Now, if we want an equation that's parallel to that, what do we know?
The slope has to be-
Slope has to be the same, right? So our equation is going to have the same slope, 3/4, right? Now, we don't know what the b value is because right now all we're trying to do is make it parallel to this. Any equation with a parallel or the same slope will be parallel, right? But they don't want just any line. They want a line that also is parallel and goes through this point. If a point is on a line, what that means is that those coordinates are a solution to that line's equation. Words are hard, math is easy. What does that mean? It means that -4, when we plug it in for x, whatever b is going to cause that to equal 6 for y. That's a solution for whatever equation we're looking for, right? So we don't know what b is, but we're going to go looking for it. We know that whatever b is has to make, when we plug in -4 for x, and we do all the math, it has to make y 6, right?
Yes.
So if we plug in -4 for x, and we plug in 6 for y, we can figure out what b has to be in order for that to be true, right? What equation are we talking about that goes through -4, 6? Well, let's find out. Multiplication of fractions is easy. You got options. You can either times by the top and then divide, or you can divide by the bottom and then times by the top. Do you want to divide first or multiply first? That's a popular choice. What's 3 times -4? -12. What's -12 divided by 4? -3. I like to divide first when I can because it makes the numbers smaller, and we all like smaller numbers. Could you have divided first? Yes. -4 divided by 4 is -1, right? Times 3 is -3.
Well, that's,
It can be easier. Division, when it works, makes numbers smaller, and we like smaller numbers. So divide first when you can, right? Add 3, we find out that b has to be 9. If b is 9 here, that means that this line will go through -4, 6. Because when you plug in -4, it will become a 6 for the y.
Damn.
So when I write my equation, it will be y equals 3/4 x, and what do we find for b? So plus 9. That's the equation of the line that's parallel to the other one. Now we need to graph it. It's in slope-intercept form. To graph something quickly in slope-intercept, there's lots of ways to do it, but the quick way is to take one point for free, right? That's the intercept. That's a free point.
9.
So 9 on the y-axis, because it's the y-intercept, right? There it is. Now, we only have 1 point. We need 2 points to graph the line. How can I find another point?
Slope.
Use slope, right?
Yeah.
I can go up 3 over 4. I could also go down 3 back 4, right? Negative 3 over negative 4 is the same thing as positive 3 over positive 4. But you only need 2 points. And then you can draw your line. So that's the equation y equals 3/4 x plus 9.
Smack to negative 4/6.
Yeah.
Now check it out. It does go through negative 4/6, right? There it is.
Yeah.
And they have the same slope, so we must have done okay.
But you know, I'm impressed with myself.
He doesn't prove it.
Right now.
Do you get picky if we don't use a ruler and make a straight line?
I would prefer it to be a straight line, yes. 23.
You have OCD.
Make my job easier. No, it just makes my job easier. I can check your work a lot easier.
Mhm.
All right. X equals 5. If I were to give this to a calc student, odds are they'd be lost. I have no idea what to do because they know how to do this, follow the steps, do the formula, y equals mx plus b, blah, 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 right? They'll probably say, when I say slope-intercept form, they'll say the slope formula instead like you guys do. But still, they know how to follow the steps. They've never had me as a teacher. You guys know what this means. X equals 5. That means all of the points where x is 5. So let's find those. Here's one point where x equals 5, 5 comma 0, right? Let's find all the points where x equals 5, like 5 comma 1, and 5 comma 2, and 5 comma negative 1, et cetera, et cetera. What kind of line is x equals 5? It's a vertical line. It's the vertical line that hits all the points where x equals 5. So that's the line x equals 5. Now what we want is the line that's parallel to that and goes through negative 7, 6. So negative 7, 6 on our diagram, or on our chart is here. Negative 7, up 6. There it is. There's negative 7, 6. Now if we want a line that's parallel, they're both going to be vertical, right? So let's draw it. Now we do need to have the equation. It asks us for the equation, right? But we're going to use that to help us figure out what the equation is going to be. That has undefined slope, so we can't do a y equals mx plus b for this. This is why the calc students get screwed over, okay? But you know how to figure out an equation of a line like this. All of these points have something in common. Think before you answer. What do all of these points have in common? X equals
5. No. I'm stupid.
the red line.
Oh.
6.
Negative 6.
Oh, negative 7.
Negative 7.
Yeah, I'm a clutch.
Check it out. We have negative 7, 0. We have negative 7, 1. We've got negative 7, 2. We've got negative 7, 3. All of the points have x equals negative 7. Check it out. It has to go through this point, right?
Yes.
So x equals negative 7 is the equation. Done.
Oh, well.
This is super easy if you know what it means, but if you don't know what it means, you're screwed, right? Make sure you know what it means because I want to give you 3 points, and I need you to know this, right? Because the whole point of the quiz is do you know your crap, and this is a great way to check.
And then it'd be the same way for y too, right? Like if you're trying to find.
Don't assume, okay? Think about what it means because eventually you're gonna forget that, and it's gonna be a coin toss. You see what I'm saying? You're gonna be like, wait, is it always x with the x, or is it not? Because when we do perpendicular, it actually changes. Okay? So know what it means, and you'll be all fine. You'll be fine. But I'm glad that you're seeing the connections. Okay? Does everybody see why this is x equals negative 7?
Yes.
All the points where x is negative 7. Again, check yourself. Are all those points have x equals negative 7 for their? Yeah. Right. Cool. 24. Again. First of all, if this is in slope-intercept form, what must our slope be? 0. Good call. A line that has 0 slope is what kind of a line?
Horizontal.
Horizontal. So y equals negative 2 is going to be a horizontal line. Here's where y is negative 2. And it's going to be horizontal. Now, if you didn't know that, you could also be like, hey, look, here are all the points where y is negative 2, right? Something negative 2. But we do know it's horizontal because the slope is 0, right? I'm glad you didn't say negative 2 for the slope. So that's y equals negative 2. We want a line that is parallel to that goes through negative 1, negative 8. That's here.
Oh my god, I'm going to freaking.
Okay?
Oh, and I know they
If it's parallel, it also has to be horizontal. All of the points on that line, again, we're doing parallel here, so it's horizontal. They're both horizontal. All the points on that line have something in common.
Why?
Y equals what?
Negative 8.
Negative 8. If you know what it means, it's super easy. If you don't know what it means, you're screwed.
Damn.
My favorite kind of question.
Dick.
Me?
Okay. We'll pause for station identification. Oh, we are.
Move down to perpendicular.
You ready to move on? Schlaffer, got a question? You sure? All right. No yawning in math class. All right. Number 25. Only thing funnier than 24. We want to do perpendicular this time, which means
It needs to
Negate.
flip and negate. So our equation is going to look like y equals flip a third. What happens when you flip a third? You get 3. Change the sign, we get positive 3. So we have 3x. We want it to go through 5, negative 2. So here's b. Let's find out what b has to be if we want to go through 5, negative 2.
Get it?
Whoa.
Whoops, sorry, I plugged in negative 3. My bad. I meant to plug in negative 2. No, I didn't. I meant to plug in 5. Oh, God, it's happening.
What?
Sorry.
Oh god.
That's what I meant to do. 5 goes with the x, right? So we get 15. If we subtract 15, we get negative 17. B is negative 17. That means our equation is y equals 3x minus 17, and we need to graph that. How do we graph that? Gross, it won't fit on the thing. Don't tell me we're going to mark these by 2. We're not doing that, okay?
Plot 6.
Here's what we're going to do.
How'd you get 17?
We need 2 points. I subtracted 15.
Oh, okay.
Yep, cool. Good question.
Yeah.
All right, so how do I plot this? Well, didn't they give us a point?
Yes.
That point's on our line, right? So let's plot that. 5, negative 2. 1, 2, 3, 4, 5, down 2. Now I've got 1 point for free. How can I get another point? We can use our slope. What's our slope? So up 3 over 1. All I need is 2 points. If I were to continue extending this downwards, we would find that, yeah, this does cross at negative 17 right off the chart. But we don't need that. All we need are 2 points. So use your resources. Be creative. I'm going to pause for station identification. I found this had to be 3 because we needed to flip and negate, right? It says perpendicular. Everybody see where I got 3?
Yeah.
I need to find out what b is, so I plug in 5 and negative 2, respectively. 15 is here. I subtract, I get negative 17. b is negative 17, so there's our equation. I need to graph that. Normally we'd go down to negative 17 up 3 over 1, but negative 17 doesn't fit. So I was clever and I said, look, I know 5, negative 2 is supposed to be on this line, right? And if I use my slope, I get another point. There it is.
That's it.
Would it hit at negative 17? Yeah, it would, right? But ain't nobody got time for that. Turn the page.
Turn the page.
Real quick, 27. They give us y equals 6. Y is 6. What's our slope?
0.
0. Even if you didn't know that, all the points where y is 6. Well, here's where y is 6 and x is 0. Here are all the other points where y is 6. It's going to be a horizontal line. We want a line that is perpendicular to that. So if we have a horizontal line,
It's gotta be.
the other one's got to be vertical, right? And we want it to go through 0, 0. Well, here's 0, 0.
Well, it's gonna be.
Vertical is going to go here. What is the equation of that line? In other words, what do all those points have in common?
X equals 0.
Y could be anything, right? 0, 1, 0, 2, 0, 3 shows up here, but x is always 0. Are you smelling when I'm stepping it?
Yes.
If you do not, come see me, okay?
Oh, look at that.
Y is 6 for this guy because here's where y is 6 on the y-axis. 1, 6, 2, 6, 3, 6 is where y is 6. Here, we drew our line. This is x equals 0 because this is all the points where x is 0. Here's 0, 0. Here's 0, 1. Here's 0, 2, right? X is always 0.
Yep.
So the equation is x equals 0.
Excuse me. Oh, you think that's bad? You should hear Bo do it.
I
Sounds like a freaking
I'd rather
nuke going
not.
on.
Okay.
So sus.
We're on page 10 now.
Jesus Christ.
I was like, we're gonna get.
Find the slope of the equation. How do I find the line?
Count it.
Pick 2 points and count it, right? Looks like I go up 3 over 3. So that means our slope of this line is what? 3 over 3, which reduces to 1. If I want to make a line that's perpendicular to that, I flip and negate, right? So negative 1. So I know my equation is going to be y equals negative x plus b. I could plug in that coordinate and solve for b, or I could use the slope and see where it crosses. Where would it cross?
This is where I'm gonna fail.
Where would it cross? It would cross at. So you can do it that way, or you can plug it in, like we did on the last page. Your choice. Come see me in homeroom if you have more questions. Watch the other reviews online. We got through more in the other class. That was the end of it, though. That was the last one. Period 3 was a great period to watch.